All right, let's take a look at a radical function to see if we can find the derivative function. So I've got this radical function, the square root of 2x plus 3, and I want to find the rate of change of that function as a function. And so that's what we call f prime of x, the derivative function. The definition for the derivative function, so f prime of x, is that limit of the difference quotient. And we'll use the h version, f of x plus h minus f of x, all divided by h. And we could either do it in stages, like I've shown before, or in one shot. I'm going to write the one-shot version down because it's not too bad in this case. So that is the limit as h goes to 0 of the square root of 2 times parentheses x plus h, right, plus 3 inside the root, and then minus the original function, which is just 2x plus 3, all divided by h. And we can't carry out this subtraction here because these roots are not the same. And order of operations is we kind of got to do inside the root before we can do anything outside the root. And there's really not much to do inside except distribute the 2 to the x plus h, and that doesn't do too much. And if we try to cheat and plug in the value 0, then we'll have a 0 in the denominator, which flag should go up there. And then in the numerator, this h would be gone, and we would have the function minus itself. So we'd end up with 0 over 0, which is indeterminate. That means some algebraic trickery needs to be processed. So here, we're going to multiply by the conjugate of that sucker. And we'll have to do that top and bottom. So the conjugate is just replacing this minus in the middle with a plus. So square root of 2x plus 2h, if I carry out that distribution there, plus 3, minus the square root of the original, oops, plus we know the conjugate, same thing in the bottom. So we keep the value of the whole limit equal. And then what we should notice in the top is we have the difference of two squares formula. So we have a thing that looks like a minus b times a plus b. And hopefully recall that the middle terms subtract out, leaving just a squared minus b squared. And that is lovely because we are squaring square roots. So some cancellation of roots is going to happen. So my new numerator is going to be 2x plus 2h plus 3. The root cancels because of the square multiplying the root by itself here and here, minus the square of this square root, which is just 2x plus 3, and parentheses are important here. The denominator we're going to hold off on distributing. We're just going to call it h times the sum of the roots. Cool thing about the numerator is once we distribute this negative, fun stuff happens, like this 2x subtracts out with that 2x, and then this 3 subtracts out with that 3, leaving only the 2h in the top. So now we've got a limit as h goes to 0. There's only a 2h left in the top, which the h in the bottom is delighted about. And we have all this in the bottom still. So next we get to say, hey, a number divided by itself is 1. Love doing that stuff, very exciting. 2 times 1 is 2, so we end up with 2 over this stuff in the bottom. So now we've got the limit as h goes to 0 of 2 over the sum of those two radicals. And now we try again. Can we let h go to 0 and see what happens? Well, this is kind of nice. There's no h on the bottom, so the 2 is like, hey, I don't care what you're doing, h, I'm still 2. Cool. And in the bottom, the only h is right here, and that is going to 0, leaving just this first square root of 2x plus 3, and another square root of 2x plus 3, and a number plus itself is twice that number, so we get 2 over 2 of those square roots in the bottom. And the 2's say, hey, I'm a number divided by myself, so 2 divided by 2 is 1. And so finally, it looks like I get 1 over the square root of 2x plus 3. Wow, that was awesome. Look at that. Question is this the right derivative function? There are plenty of places we could have had an error there, so we're going to check by looking at this graph and picking a point and seeing if this gives us the right slope at that point. So let's give it a shot. So we think this circled thing down here is the slope function for the original. GeoGebra, please. So I've got f of x equals the SQRT, and there is a button for that here somewhere too. We can just type it, 2x plus 3. All right, so there's my function right there, and yeah, that'd be an easy point to use, the intercept, because then I just need to find the slope there. And we think the slope function, let's call that d for derivative, d of x, we think that is equal to 1 over the SQRT, parentheses, of 2x plus 3. Oops, I mistyped that. 2x plus 3. And we want to know what is the slope at 0. So the green function is the one I'm looking at. The blue one is supposed to be the slope function. And I want to know what is the slope when x is 0. And it says it's that number right there. Ooh, that's a nice number. Okay, stuck with it. So then I think that's the slope. Oh, they're calling it a here. That's kind of cute. So then I should just be able to type y equals a times x plus 2. Ooh. Oh no, that's not right. Why did I say 2? If f is 0, I get the square root of 3. Oh, okay. SQRT. Oh, I thought that was 2, square root of 3. Okay. So I'm looking at the point, and actually let me back up in case that wasn't clear. Let's delete and start over. All right, so I'm looking at the point 0, comma, f of 0. So that right there. For some reason, I looked at that, thought it was 2 earlier. It's clearly not 2. It's the square root of 3, which you can see if you plug in 0 here, you get the square root of 3. So that's the point I'm aiming at, and that square root of 3 is the y-intercept. The slope is plugging in 0 to the slope function. So I'm going to call the slope m, and m is going to be d of 0. Okay. So then the tangent line there should be y equals that m I just calculated times x, and then I add on the y-intercept, which I could just say is f of 0. And bang, that looks pretty tangent right there. So let's hide the slope function, zoom in there. Looks like a pretty good tangent line right there. And if we weren't completely convinced, we could try another place and see what's happening. Like if we plugged in, is there a way to pick a nicer pair of numbers? 2 times 3 is 6. Yeah, if we try the point 3, f of 3, that gives us some whole numbers to work with. So that's the point 3, 3. And then the slope would just be evaluating, instead of at 0, we would evaluate at 3. So let's see, if I use the point slope formula, y minus y1 is just f of 3 equals the slope, well, that's the derivative function at 3 times x minus 3. And hopefully what I will see is if I turn off some of this other stuff, like that one there and that one there, and I scroll over to the point 3, 3, that my new cute blue graph looks pretty tangent to the green graph that I started with. Check, looks like it works all right. So we do have, where'd you go? There you are. a function, and now we have its slope function here, the derivative function. Thanks for playing.